So the first thing that you need to know in order to write a nuclear equation is the nuclear particles, the symbols, the charge, and the mass. So there's more particles than are listed here, but these are the 5 that you have to know. So the first one is alpha. An alpha particle can sometimes have like a little alpha Greek letter symbol, but in equations you want to use this symbol just because of the mass and the atomic number that you're going to need. So essentially an alpha particle is actually a helium nucleus. So it's going to have a mass of 4, you see there, a charge of +2, which means it's going to have 2 protons in the atomic number. A beta, again, can be this Greek letter beta, but this one is actually more useful when you talk about your equations. So it's 0 over -1e, has a charge of -1 and a mass of 0. Gamma is the unique one. Gamma is the one that has no charge and no mass. It has a symbol of a gamma Greek letter. This is the one that's hardest to write in a nuclear equation because it has no charge or mass. It doesn't affect the nucleus of the parent nuclide, so you kind of just assume that gamma radiation is always there. You have a positron, which is basically a beta particle with a +1 instead of a -1. So it's a +1 charge and a mass of 0. And then a neutron, which is just a regular neutron that you find in the nucleus, has a mass of 1 and a charge of 0. So to write the nuclear equations, what you're going to look at is you're going to look at the decay. It's going to be decay, which is another word for decomposition. So if we look real quick, you're always going to start with a single, and that's called a parent nuclide. It is going to have a number on the top, which represents the mass number, and it's going to have a number on the bottom, which represents the atomic mass. Just like you would write an isotope symbol, for example. And then what's going to happen is you're going to have a single arrow because it's going to decay, and you're either going to be given one or two things. You're either going to be given the particle that comes out and asked to do what we call the daughter nuclei, which is the thing that comes out of it. Or like down here, you're going to be given the daughter and then have to go and figure out what particle comes out. So it all starts with what we call the parent nuclide. It's going to be the one that starts the reaction. It's the one that decays. It's the radioactive one. And what you're going to do is you're always going to subtract the numbers that you see. So you see you start with 42. You're going to subtract 0. So if I do 42 minus 0, that's going to leave me with 42. Do the same thing to the atomic mass. I have 19. Now in this case, I'm going to minus a -1. So if you remember your math skills, if you take 19 minus a -1, it ends up adding 1. So you get 20 as the atomic number. Now, the symbol is not going to be K. It's no longer potassium. Remember, nuclear equations are unique because they change the nucleus. So what you have to do is you have to reference your periodic table, find the element with the atomic number 20, and you figure out that it is calcium. Okay, let's move on to number 2. Same thing. You're going to do 9 minus 9, and that's going to give me 0. And then you're going to have 4 minus 4, which again is going to give me 0. Well, in this case, I'm given the daughter nuclide. That's what that is. And the way I know that is because it has an element symbol from the periodic table. So in this case, I'm finding the particle, and the only particle with a 0 over 0 would be gamma. Okay, keep going. I'm going to do 6 minus 4 to give me 2. And then 3 minus 2 to give me 1. So this case, this is an alpha particle. So I'm finding the daughter nuclide. So I look to the atomic number 1 and I find out this is hydrogen. Okay, this time again, this is an alpha, so I'm finding the daughter nuclide. So I'm going to do 239 minus 4 to get 235. And then 94 minus 2 to get 92. I look up 92 on the periodic table and find out that it is uranium. Okay, for 5, I'm given the daughter. So what I'm trying to find out is the particle. So you see here, you have a blank space. So if I'm going from 235 to 231, the difference there, what was subtracted, is 4. Then the same, I went from 92 to 90, so the difference there is 2. The only particle with 4 over 2, it has to be an alpha, He. Now, this one's the most complicated, a little bit more. You need to find the parent now. So remember, the parent, you just keep subtracting, so if you want to go the opposite way, you add. Don't forget there's a 3 here. What that means is you have 3 of these. You have 1 over n, 1 over n, 1 over n. So you have to add them all. So you would do 1, 2, 3, or 3 times 1, 3 plus 92 plus 142, and that's going to give you 236. Same thing for the atomic number, 0 times 0, 0 plus 0 plus 0, or 3 times 0, 36 plus 56, and you get 92. And then I look up 92 on the periodic table, and I find my parent was uranium, U. Okay, this is the next kind. This time we have slightly different definitions. What you're going to do is you're going to complete the equation like we did before, but now you're going to identify the type of decay. You're actually going to write the term, which one it is. Was it alpha, was it beta, etc. Same thing we did the last time, though, as far as filling in. So in this case, I have the daughter particle, so I'm trying to find the actual nuclear particle that comes out. So 234 minus 234 is 0. 90 and then 91, the only way to have that happen is I had to add 1. So I must have a negative 1, which is going to tell me that is a beta particle. So the only way the atomic number is going to go up is actually if you subtract it. Remember, minus negative turns into a positive. Here I have an He, 4 over 2. Well, I can write on the line right away, that is the alpha particle. So when they give you the particle, it's easy to tell what it is. Remember, I'm still subtracting. So I do 234 minus 4 to get 230. And then 91 minus 2 to get 89. Look up 89 on the periodic table, and it is actinium. For 9, again, they just give you the particle. So I'm going to tell you that it's alpha. 220 minus 4 is going to give me 216. 86 minus 2 is 84. And then I'm going to find out that it's polonium. Finally, again, we're given a particle. In this case, it's another beta. So I'm going to do 216 minus 0.